Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Solutions for Force and Newton's Laws of Motion, Class 9, Chapter 9. Questions from the chapter. Which of the following has more inertia? A rubber ball and a stone of same size? A bicycle and a train? A 5 rupee coin and 1 rupee coin? Inertia is the measure of the mass of the body. The greater is the mass of the body, the greater is its inertia, and vice versa. So mass of a stone is more than the mass of rubber ball for same size. Hence the inertia of stone is greater than that of a rubber ball. Similarly, mass of train is more than the mass of bicycle. Hence the inertia of train is greater than that of bicycle. And mass of 5 rupee coin is more than 1 rupee coin. Hence the inertia of 5 rupee coin is greater than that of 1 rupee coin. In the following example, try to identify the number of times the velocity of a ball changes. A football player kicks a ball to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards the player of his own team. Also identify the agent supplying the force in each case. The velocity of football changes 4 times. First, when football player kicks to another player. Second, when that player kicks the football to the goalkeeper. Third, when the goalkeeper stops the football. And fourth, when the goalkeeper kicks the football towards the player of his own team. Agent supplying the force. In the first case, first player. In the second case, second player. In the third case, goalkeeper. In the fourth case, goalkeeper. Explain why some of the leaves may get detached from the tree if we vigorously shake its branch. Some of the leaves of the tree get detached when we shake its branches vigorously because branches comes in motion while the leaves tend to remain at rest due to inertia of rest. Why do you fall in the forward direction when a moving bus brakes to a stop and falls backward when it accelerates from rest? In a moving bus, a passenger moves with the bus due to inertia of motion. As the driver applies brake, the bus comes to rest, but the passenger tries to maintain the inertia of motion. As a result, forward force is exerted on him. Similarly, the passenger tends to fall backwards when the bus accelerates from rest position because when the bus accelerates, the inertia of rest of passenger tends to oppose the forward motion of the bus. Hence, passenger tends to fall backwards. If action is always equal to the reaction, explain how a horse can pull a cart. According to Newton's third law of motion, action force is equal to the reaction force but acts on two different bodies and in opposite directions. When a horse pushes the ground reacts and exerts a force on the horse in forward direction. This force is able to overcome friction force of the cart and it moves. 6. Explain why is it difficult for a fireman to hold a hose which ejects large amount of water at high velocity. When a fireman holds a hose which is ejecting large amount of water at high velocity, then the reaction force is exerted on him by the ejecting water in the backward direction. This is because of Newton's third law of motion. As a result of the backward force, the stability of fireman decreases. Hence, it is difficult for him to remain stable while holding the hose. 7th, from the rifle of mass 4 kg, a bullet of mass 50 grams is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. So the mass of rifle here is 4 kgs. Mass of the bullet M2 is 50 kilograms, that is 0.05 kg. Recoil velocity of the rifle is V1. Bullet is fired with an initial velocity V2, which is 35 meter per second. Initially the rifle is at rest, thus its initial velocity is 0. Total initial momentum of rifle and bullet system is M1 plus M2 multiplied by V. Total momentum of the rifle and bullet system after firing is M1 V1 plus M2 V2. Putting the values in this equation, we get 4 V1 plus 1.75. According to the law of conservation of momentum, total momentum after firing is equal to total momentum before firing. So 4V1 plus 1.75 is equals to 0. So we get 4V1 is equals to minus 0.4375 meter per second. The negative sign indicates that the rifle recoils backward with a velocity of 0.4375 meter per second. Two objects of mass 100 and 200 grams are moving along the same line and direction with the velocity of 2 and 1 meter per second respectively. They collide. After the collision, the first object moves at velocity of 1.67 meter per second. Determine the velocity of the second object. So the mass of first object is 0.1 kg. Mass of second object is 0.2 kg now. Velocity of the first object before collision V1 is 2 meter per second. Velocity of second object before collision V2 is 1 meter per second. So the velocity of first object after collision is V3 1.67 meter per second and velocity of second object after collision is V4. Now according to the law of conservation of momentum, total momentum before collision is equals to total momentum after collision. Therefore, M1 V1 plus M2 V2 is equals to M1 V3 plus M2 V4. Now putting the values here, we get V4 is equals to 1.165 meter per second. Hence, the velocity of the second object after the collision is 1.165 meter per second. Back exercises. First, an object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity? If yes, state the condition that must be placed on the magnitude and direction of the velocity. If no, provide a reason. So when an object experiences a net zero external unbalanced force in accordance with the second law of motion, its acceleration is zero. If the object was initially in the state of motion, then in accordance with the first law of motion, the object will continue to move in the same direction with same speed. It means that the object may be traveling with non-zero velocity, but the magnitude as well as the direction of the velocity must remain unchanged or constant throughout. Second, when a carpet is beaten with a stick, dust comes out of it. Explain. The carpet with dust is in the state of rest. When it is beaten with a stick, the carpet is set in motion, but the dust particles remains at rest. Due to inertia of rest, the dust particles retain their position of rest and falls down due to gravity. Third, why is it advised to tie any luggage kept on the roof of the bus with a rope? In a moving vehicle like bus, the motion is not uniform. The speed of the bus varies and may apply brakes. Suddenly, the luggage will resist any change in its state of rest or motion. Due to inertia, luggage may fall. To avoid fall of luggage, it is tied with rope. A batsman hits a cricket ball which then rolls on the level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because A. The batsman did not hit the ball hard enough. B. The velocity is proportional to the force exerted on the ball. C. There is a force on the ball opposing the motion. Or D, there is no unbalanced force on the ball, so the ball would want to come to rest. The correct answer is C, there is a force on the ball opposing the motion. It is because the ball slows down and comes to rest due to opposing force of air resistance and frictional force on the ball. A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration and the force acting on it if its mass is 7 metric tons. Initial velocity here is 0. Distance traveled is 400 meters. Time taken is 20 seconds. We know that S is equals to ut plus half at square. So putting the values, we get acceleration is equals to 400 into multiplied by 2 upon 400, that is 2 meter per second square. Now mass is 7 metric tons, which is equals to 7000 kg. So acceleration here is 2. So putting the values in force is equals to mass into acceleration, we get force 14,000 newtons. A stone of 1 kg is thrown with a velocity of 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? Initial velocity of the stone is 20 meters per second. Final velocity of stone is 0. Distance covered by the stone is 50 meters. We know that V square is equals to U square plus 2AS. This can be written as V square minus U square is equals to 2AS. So now putting the values, we can get acceleration, which is equals to minus 4 meter per second square. Now force of the friction here is mass into acceleration. So putting the values, we get force is equals to minus 4 Newton. A 8000 kg engine pulls a train of 5 wagons, each of 2000 kg, along a horizontal track. If the engine exerts a force of 40,000 newtons and the track offers a frictional force of 5,000 newtons, then calculate A, the net accelerating force, B, the acceleration of the train, C, the force of wagon 1 on wagon 2. So first force exerted by the engine is 40,000 newtons. Frictional force offered by the train is 5,000 newtons. So net acceleration force will be equal to force exerted minus frictional force, that is 40,000 minus 5,000, which is equals to 35,000 newtons. B, acceleration of the train is A. Now net accelerating force is 35,000 newton. Total mass of 5 wagons will be 5 into 2000, that is 10,000 kgs. So F is equals to MA. Now putting the values, we get acceleration 3.5 meter per second square. See the force of wagon 1 on wagon 2. Wagon 1 will have to exert a force on all 4 wagons next to it. So the mass of the other 4 wagons will be 2000 multiplied by 4, that is 8000 kgs. Force is equals to MA. Putting the values, we get force 28,000 newtons. An automobile vehicle has a mass of 1500 kg. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.5 meter per second square? So mass of the vehicle here is 1500 kgs. Final velocity is 0 because finally automobile stops. Acceleration here is 1.7 meter per second square. So from Newton's second law of motion, F is equals to M into A. Putting the values, we get force is equals to minus 2550 Newton. Negative symbol symbolizes that force is acting in the direction opposite to the motion of the vehicle. What is the momentum of an object of mass m moving with velocity v? mv whole square, mv square, half mv square, or mv? The correct answer is mv. Using a horizontal force of 200 Newton, we intend to move a wooden cabinet across a floor at a constant velocity. What is the frictional force that will be exerted on the cabinet? The cabinet will move with a constant velocity only when the net force on it is 0. Therefore, the force of friction on the cabinet is 200 newtons in the direction opposite to the direction of the motion of cabinet. Two objects, each of mass 1.5 kg, are moving in the same straight line but in opposite direction. The velocity of each object is 2.5 meter per second before collision, during which they stick together. What will be the velocity of combined object after the collision? So the mass of the first object is m1, which is equals to mass of second object m2, 1.5 kgs. Velocity of m1 before collision is 2.5 meter per second. Velocity of m2 moving in opposite direction will be, before collision, will be minus 2.5 meter per second. Let v be the velocity of the combined object after collision. By law of conservation of momentum, total momentum after collision is equals to total momentum before collision. So m1 plus m2 whole multiplied by v is equals to m1 u1 plus m2 u2. Now putting all the values here, we get v is equals to 0 meter per second. So the velocity of combined object after collision is 0. According to the third law of motion, when we push an object, the object pushes back on us with an equal and opposite force. If the object is a massive truck parked along the roadside, it will probably not move. A student justifies this by answering that two opposite and equal force cancel each other. Comment on this logic and explain why the truck does not move. The student's justification is incorrect since the action and reaction always apply to a different body, hence cannot be cancel each other. Also, the truck has a huge weight, so it will generate greater frictional force between its tires and the ground. Hence, the truck will not move until a force greater than the frictional force is applied to it. A hockey ball of mass 200 grams traveling at 10 meter per second is struck by a hockey stick so as to return to along its original path with a velocity of 5 meter per second. Calculate the change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. So the mass of the ball is 200 grams, that is 0.2 kgs. Initial speed of the ball is 10 meter per second. Final speed of the ball is minus 5 meter per second in opposite direction. Initial momentum of the ball is mu, which will be equal to 2 kg meter per second. Final momentum of the ball will be mv, which will be equal to 1 kg meter per second. So the change in momentum is equals to difference in the momentum, that is mu minus mv. Putting the values, we get 3 kg meter per second. A bullet of mass 10 grams traveling horizontally with the velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 second. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. Initial velocity is 150 meter per second. Final velocity is 0 since the bullet finally comes to rest. Time taken here is 0.03 second. According to the first law of motion, v is equals to u plus at. Putting the values, we get acceleration, which is equals to minus 5000 meter per second square. Negative sign indicates that the velocity of the bullet is decreasing. According to the third equation of motion, v square is equals to u square plus 2as. Now putting the values here, we can find the distance, which is equals to 2.25 meters. Hence, the distance of the penetration of the bullet into the block is 2.25 meters. From Newton's second law of motion, F is equals to m into a. Mass of the bullet is 10 grams, that is 0.01 kg. Acceleration is minus 5000 meter per second square. So force will be, putting the values, we get minus 50 newtons. Hence the magnitude of force exerted by the wooden block on the bullet is minus 50 newtons. An object of mass 1 kg travelling in a straight line with a velocity of 10 meter per second collides with and sticks to the stationary wooden block of mass 5 kg. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of combined object. So the mass of the object m1 is 1 kg. Velocity of the object before collision is v1 10 meter per second. Mass of the stationary wooden block m2 is 5 kg. Velocity of the wooden block before collision v2 is 0. Total momentum before collision is equals to m1 v1 plus m2 v2. Now putting the values here, we get the total momentum before collision 10 kg meter per second. It is given that after collision the object and the wooden block stick together. So the total mass of the combined system is equals to m1 plus m2. Velocity of combined object is v. So according to the law of conservation of momentum, total momentum before collision is equals to total momentum after collision. That is m1 v1 plus m2 v2 is equals to m1 plus m2 multiplied by velocity. Now putting all the values here, we can get the velocity of combined object is 1.67 meter per second. An object of mass 100 grams is accelerated uniformly from a velocity of 5 to 8 in 6 seconds. Calculate the initial and final momentum of the object. Also find the magnitude of the force exerted on the object. So the initial velocity is 5 meter per second. Final velocity here is 8 meter per second. Mass of the object is 100 kgs and the time taken is 6 seconds. So the initial momentum is equals to mu, which is equals to 500 kg meter per second. Final momentum will be mv, which is equals to 800 kg meter per second. Force exerted on the object is mass into acceleration. And we know acceleration is change in velocity upon time. So putting the values, we get acceleration is equals to 3 by 6. Now putting all these values in the force is equals to ma equation, we get force 50 newtons. Akhtar, Kiran and Rahul were riding in a motor car that was moving with high velocity on an expressway when an insect hit the windshield and got stuck on the windscreen. Akhtar Kiran started pondering over the situation. Kiran suggested that the insect suffers a great change in momentum as compared to the change in momentum of the motor car because change in the velocity of insects was much more than that of the motor car. Akbar said that since the motor car was moving with a large velocity, it exerts a larger force on the insects and as a result, the insects died. Rahul, while putting an entirely new explanation, said that both the motor car and the insect experience the same force and the change in their momentum. Comment on these suggestions. Rahul gave the correct reasoning and explanation that both the motor car and the insects experience the same force and a change in their momentum. According to the law of conservation of momentum, initial momentum before collision is equals to final momentum after collision. So, equal forces are exerted on both the bodies, but because the mass of the insect is very small, it will suffer a greater change in velocity. How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 centimeters, takes its downward direction acceleration to be 10 meter per second square? So mass of the dumbbell here is 10 kgs. Distance covered by the dumbbell is 80 centimeters, that is 0.8 meters. Acceleration in downward direction is 10 meter per second square. Initial velocity is 0. Final velocity of the dumbbell when it is about to hit the floor is v. Now according to the third equation of motion, v square is equals to u square plus 2as. Putting all the values here, we get v is equals to under root 16, which is equals to 4 meter per second. Hence, the momentum with which the dumbbell hits the floor is equal to m into v. Putting the values, we get 40 kg meter per second. Thanks for watching. Please do like, share and subscribe.